This is a good question. Average velocity. So you guys are telling me you were able to find the average velocity of the object over the following intervals. You're able to do from 1 to 4, and from 1 to 3, and from 1 to 2? That's no problem. It's just when they say 1 to 1 plus h, and that gave us a headache. Okay, let's see if I can help with that one. So, I think to understand it, I better do one of the other ones. Or at least start it, maybe if I don't even do the whole thing. Okay? So the function is, and this is problem 9. And I know you can't see what I'm writing yet, but I'll show you in a second. I just want to write the function down first. S of t equals negative 16t squared plus 128t. Okay? And so they want me to find the average velocity. It's also called sometimes the average rate of change. So let me show you that. Here's my function. And what I'm supposed to find is sometimes called the average rate of change, or AROC for short. No one else calls it AROC. I do. Well, I do that because then when I want to talk about the slope of a tangent line, I can call that an instantaneous rate of change. IROC for short. So we have AROC and IROC. But people do call it this, average rate of change, instantaneous rate of change. Okay. So what's the game? You guys did the interval 1, 3. That was B. And how'd you do it? You did. Well, I know what was in the denominator, 3 minus 1. Am I right? What was in the numerator? How'd you get 240 minus 112? You did S of 3, right? Minus what? S of 1. Is that what you did? It's basically y2 minus y1 over x2 minus x1. This is AROC. Are you with me? Well, I want to show you on a picture what we just did. I have a downward parabola. And I don't know exactly what it looks like, but I probably should have a better picture. But basically, it's this, guys, right? You're finding the slope of a secant line as you go from 1 to 3. Something like that. Okay? Now, they say for part D, we want to go from 1 to 1 plus h. Well, I'm telling you that to find AROC, it's not going to be any different. Do you know what's going to be in the numerator? It's going to be S of something. S of what? 1 plus h. Minus something else. S of 1. All over. Well, it's going to be 1 plus h minus 1. So someone said it's going to be over h, and you're right. It's going to be over h. Does that make sense? Now, I guess that numerator we better work on a little bit. I always tell people when they're simplifying something like this, work on this one first. We know what S of 1 is already. 128 minus 16, so what is it? 112? Is that what it is? So we are going to subtract 112 from whatever we get for S of 1 plus h. Now, that's a little more work. What I have to do for S of 1 plus h, okay, is I'll have to do negative 16 times 1 plus h squared plus 128 times 1 plus h, and I'm running out of room. So I better spread it out a little bit on the next line. So there we are so far, guys. Let me write a big equals and try to simplify a little bit. So let's see, I have negative 16 times, isn't this 1 plus 2h plus h squared? When I square a binomial, I get a, thank goodness. Don't put 1 plus h squared there, or I'll have to go home. Right? Okay, plus 128 times 1 plus h, minus 112, all over h. Okay? Some of you by now are, what the heck is he doing? You might be wondering what h is, right? H is the denominator. Hey, what was the denominator in the problem with the numbers up here? It was 3 minus 1. It was what? 2, right? Up here we went from 1 to 1 plus 2. You see, h is really this distance here, h. Does that make sense? Oh, you can't see it, sorry. H is the distance from the 1 to the 3. It's like your delta x. That's what h is. All right, let's continue. At this point, it's just algebra, but that's kind of fun. Let's see. I have negative 16 minus 32h minus 16h squared plus 128 plus 128h minus 112 all over h. Okay. Anything happen next? What would you do next? Combine like terms. Okay, so let's see what happens. We get, in the next line, if I have negative 16h squared, right? What else? Yeah, 128 minus 32, is that plus 96h? Plus 96h. And then let's see, I have 128 minus 112 is what? 16 minus 16 is? Da, da, da. Coincidence? It worked. And thank goodness the numbers went away, because I know what you all want to do. Each and every one of you wants to get the h out of here. About 5 more minutes, right? Well, no. I mean, we want to get the h out of here. But we can't because of the number. You can't just cancel. That's that mad slasher inside each one of you wants to cancel. But, like some people cancel these h's. No! You can't do that. You have to factor out the h in order to cancel it. So if I do something like this, now I can get the h out of here. Don't leave yet. So, what do we have? The answer would be negative 16h plus 96. Negative 16h plus 96. Cool. Hey, what good did that do, right? Well, okay. Let's go back to part A, B, and C. Part B, what did I say the h was in part B? Yeah, so what did it equal? Isn't it true up there that h equaled 2? You guys with me? So let me show you a faster way to do part B now that I did all this work. Put in a 2 for h. What's 96 minus 32? 64. Is that the answer you guys got for part B? Sweet! Give me another one. Part C, what'd they ask you? 1 to 2. So what does h equal? If I'm going from 1 to 2 in part C, what does h equal? H equals 1, because it's the distance between the 2 points. So let me try it. 96 minus 16 is 80. Was the answer to part C 80? Nice. I can do any secant line instantly because I computed AROC. AROC is the slope of the secant line. Cool. So I guess the question is, how do I finish today's class? And maybe I finish with this calculus idea. It's really not until chapter 3, but you asked the question, so I have to go with it. We're finding the slope of secant lines. First we did from 1 to 3. No, first we did from 1 to 4. Then we did from 1 to 3. Then we did from 1 to 2. Now if I want the slope of the tangent line, right there at 1. If I want the slope of the tangent line right there at 1, and if my computers would actually work. That's funny. It just froze on me. I guess I'm done. Weird.